Okay, so just want to make a quick video on this homework task, and this task came from the 2019 paper. It was question 11 and it was worth 7 marks. So it's worth 7 marks, so chances are it's probably a tricky enough little question, and there's one or two things to point out. So all I've got up in the top right hand corner is the stress and strain section out of formula book. So you will be provided with that. You'll have it in a book. And this is what you'll have. So you'll have the question and the section from the book. So looking at the question, a punch will be used to produce a hole through a sheet of aluminium. The diameter of the hole is 0.2 meters and the thickness of the aluminium sheet is 0.004 meters. We're asked to find we're told the ultimate shear stress at aluminium is 50 megapascals, and we're asked to find the force needed to punch through the aluminium sheet. So, first thing we need to spot is that this isn't a tensile or a compressive type of question. Why? Because what's going to happen is we have one force acting this way, down in the punch, and the other force will be acting against it. So it will be in shear. So, first thing to point out, anytime you're dealing with the punch, and we're actually told it here, is we're dealing with shear stress. So I can go up to shear stress and have a look, and I can see shear stress is equal to force over area. So shear stress is equal to force over area. Okay. So tau is equal to force over area. And I can fill in what I know. So I know I'm told F is what I'm looking for. So I'm looking for force. Tau is equal to 50 megapascals. So 50 MPa. And area. Well, I don't know area. And we might have to have a bit of a think about what area we're dealing with. But what I do know is that the diameter of the hole is 0.2 meters. And the thickness T is equal to 0.004 meters. Okay, so now we have a question on what sort of area are we dealing with, and it's not immediately obvious because it's a shear stress question. You're trying to think of what area is the punch going to cut through. So here's one I made earlier. If I have a circular punch and you're trying to think about what shape or what area is that punch going to cut, it's actually going to cut this red sort of area. So your punch is going to come down and hit a circle type shape, and your punch has to slice through the strip of that circle. So if I can add a bit of color to this again. Something's going around there. Gotta get rid of that one. Okay, so on the one above, if we look at it, our punch is only going to be in contact with the red part of that strip. That's the bit your punch has to come through. So your punch hits that top circle and it has to slice through the 0.004 meters of material. So the first thing I need to do is I need to get the circumference of this area, of this top circle. So I've got a circle. That's the first thing my punch comes into contact with. So ignoring the thickness, I'm looking at the circumference of a circle, which is pi times diameter. So in our case, it's equal to 0.2 times 3.14. And 0.628 meters. So now I know the circumference of that circle. If I multiply that circumference by the thickness we were told, 0.004 meters, then I have the total area that your punch would be in contact with. So my area is equal to 0.628, the circumference, times the thickness, 0.004. And that's equal to 0.002512 meters. Or if you want to write it in engineering terms, 2.5 by 10 to the minus 3 meters. It doesn't matter which way you write it. You should get comfortable with this sort of notation as an engineer. If you're struggling with it, just keep all the numbers in it. Okay. So when we look at our formula now, tau, force and area. I know tau, so I know the shear stress. I know the area, so I can fill in my area. Is 2.5 by 10 to the minus 3 meters, and I can rearrange to find force. So if tau is equal to force over area, or shear stress is equal to force over area, then shear stress times area is equal to force. Now force should be in newtons per meter. Force should be in newtons. So what I'm going to have is megapascals are the same as newtons per meter squared. When I multiply that by meter squared, I'll just be left with newtons. But anyway, so 50 megapascals, 50. Now be careful, when you see that capital M in front of a unit, you need to remember that's mega and it stands for by 10 to the power of 6. So 50 by 10 to the power 6 times my area, 2.5 by 10 to the power of minus 3 equals F. Get your calculator, let it do all of the hard work for you, and it will tell you F is equal to 125,000 newtons, or if you want to rewrite it, 125 kilonewtons. And that will get you your 7 marks. So it is a tricky question. Just looking through the marking scheme very quickly, you would have got 1 mark for reorganizing that the cut area is the circumference times the thickness, 1 mark for the correct substitution of values, 1 for the correct answer for area, a mark for converting megapascals to pascals, 1 mark for rearranging in terms of F, 1 mark for correctly substituting the values, and 1 mark for the correct answer at the end. So it was a tricky question. There were a few marks to be picked up, but that is probably as hard a question as the stress and shear stress questions could be, in my own opinion anyway. Anyway, if you have any questions, just let me know. If you want me to go through anything, just let me know in class and we'll take a more detailed look. Okay, thank you.